Hello, I am Paul Miles with the International Society for Biblical Hermeneutics, and I am here with Dr. Marcus Ross, who is the owner of Cornerstone Educational Supply and the former director of the Center for Creation Studies at Liberty University. And he is here today to speak about feathered dinosaurs. Thank you so much for joining us, Marcus.
Paul, it is delightful to join you and the ISBH here for this conference. Thanks so much for putting it on, and it's really exciting. So I guess today, as we were going through our rapid fire set of talks, I'm going to be discussing a little bit about the question about dinosaurs and feathers, what the fossils say about this, and what the implications for young Earth creation are on this. And so I'm going to share my screen and bring up some slides for this. And Paul, you just let me know if that is visible to you.
Looks great. Appreciate you.
All right, very good. So first up, I want to give a big thanks to my co-author, Dr. Matt McLean, and some of my other co-authors who also worked with me on a paper recently that was published in Answers Research Journal looking at the question of Archaeopteryx. This particular presentation was one that Dr. Matt McLean and I co-presented as a seminar or kind of a workshop at the International Conference on Creationism hosted last August at Cedarville University, or July, I think, at Cedarville University. So a lot of this is the material that I presented, but some of it is also Dr. McLean. So thanks to him for helping put this presentation together. And we're going to do a shortened version of this talk. We had a great event at ICC. We would talk for about 15 or 20 minutes and then take questions from the audience, and really just had great dialogue and discussion. For our purposes here, we're going to breeze through a few of the topics. The 4 topics that we covered and that we'll cover very briefly here include dinosaur anatomy and identification. We're going to take a brief look at modern bird feathers and some types of fossil birds and what they look like. We're then going to make a quick pivot over to the argument and the evidence of dinosaurs with feathers and feather-like structures, and then take a look at some ideas that we have in creationism that will help us sort out the issues as we see them. So topic number 1 here, dinosaur anatomy and identification. This is going to be very cursory, very quick. Oops, yikes. It's also going to be too fast. There we go. So what I want to impress upon us right now is that dinosaurs or Dinosauria is a particular group of organisms that are defined and diagnosed by anatomy. We've all picked up a package of plastic prehistoric animals at some, dollar type store or what have you. I remember getting these when I was a kid, when they were like the only dinosaur toys that you could find. And there was a lot of things that came in that, and most of them were dinosaurs and some of them weren't. But it said dinosaurs up on the very top to make sure everybody bought them. But how do we know what is a dinosaur versus what is not? So there's a lot of steps to get to the slide that I'm showing you here. But one of the things that we recognize about dinosaurs is that from Triceratops all the way to Tyrannosaurus, there are certain types of anatomical features that they all share. Here we've got a couple of different bones of dinosaurs. We have the humerus, that is the upper arm bone. We have the assemblage that we call the pelvis. This includes the pubis, the ilium, and the ischium. 3 bones in here. And then we're going to zoom in on the tibia, which is the shin bone of dinosaurs. So for example, all dinosaurs have a crest of bone, a little wing of bone that extends from the upper portion of the humerus. In fact, we can get more specific. It is found within the upper 30%. It's at least 30% down from the top of the humerus itself. And there's this little crest of bone called a deltopectoral crest. And what that means is that the deltoid muscles, which for us are on the top of the shoulder, and the pectoral muscle, which for us is in the front of the chest, both of those have an insertion point onto this bone right over here and this little wing on this that helps to pull the arms inward for the dinosaurs. Now, whereas our deltoid attaches on a different spot and raises our arm upward, it's not exactly what was going on with the dinosaurs, a little bit different there. In the pelvis, the three bones of the pelvis come to a point in the center where there is a hole. We refer to this as the acetabulum. That's the cup where the femur sits in. For us, we have a big ball that sits in the cup of the acetabulum in our hip. But in dinosaurs, that cup, that acetabulum, is perforated. It has a hole. You could look straight through it through the other side. And so dinosaurs have this peculiar feature where the three bones don't come to a complete connection point in the center. Rather, there is this hole. And then one last thing that I'll point out on the tibia here is that at the end of the tibia, there is an ankle bone called the astragalus. We have that in our ankle as well, but the astragalus on dinosaurs is a little unique in that it wraps around the bottom of the tibia, this part right over here, wraps around it and has a wing, kind of what we call an ascending process of the astragalus. So on the shin bone, there is an ankle bone that wraps around it and extends upward towards the knee. And all dinosaurs share these features. So when we're hunting through and looking at an animal that otherwise has a certain group of characteristics that we might say links it with, say, crocodilians, dinosaurs, and pterosaurs, a big group there called Archosauria. If we find these features in addition to the ones that help us identify the archosaurs, then we know that we're looking at a dinosaur, for example. So there's a bunch of things in that plastic bag of stuff that we can get rid of. Dinosaurs are not pterosaurs. They're not plesiosaurs. They're not Dimetrodon. That's a synapsid, a mammal-like reptile, as they've previously been called. But the other things here, regardless of how accurate those toys might be, will qualify as being dinosaurs. So this is important that we understand that dinosaurs are defined anatomically and not simply as big lizardy things that stand on legs underneath their body. They do that, but there are very specific and diagnostic features of them. So we need to know what a dinosaur is in order to ask our question about whether dinosaurs have feathers. Now that we understand that there's some strong anatomy behind this, let's take a look briefly at feathers. Now, we think about feathers on birds and they're familiar structures to us, but we don't know them deeply. We know them on the basis of their coloration of the plumage, which is really pretty. We know a few features and structures of them. One of the science kits that we send out for a curriculum actually has the students look at a feather under a microscope to get a better understanding of the structures involved. So one of the things that we know about feathers is that they are what we call integument. That is, they are generated from within the skin and come out of the skin, much like hair. So hair is an integument, and so are feathers. They're formed in different ways and from slightly different materials, but they both count as integument because they're coming out of the skin. They're not part of the skeleton. They're not bone material. And they are able to regrow and get shed. So feathers can be sloughed off. That happens when a bird would molt, for example, and you can also trim them. We had chickens for a little while and we had to clip their wings. And first time that we did that, I didn't really know, what does that even mean? Do you have to like chop off the wing or something like that? No, it simply means that you are taking scissors and cutting the feathers so that the feathers aren't going to help the chickens flutter over a fence, for example. And those feathers will regrow, and clipping those feathers does nothing to harm the animal any more than cutting your hair, does nothing to harm you. Now, feathers are different from hair in a couple of ways. They are hollow structures where hair is usually solid, and they are hierarchical. They branch in tree-like types of patterns. They are composed of a material called keratin, and so is hair, and so are fingernails, and the beaks of birds are made of keratin. Feathers are made of a particular arrangement of keratin that we call beta keratin, or scientists often are now calling, let's see. Sorry, I just forgot. Had the word in my mind beforehand. Proteinaceous beta keratins, or yeah, that sort of thing. So keratin is a protein, and when it is constructed to form feathers, it forms in kind of a helix sort of pattern. Alpha keratins tend to form plates. So not only are feathers made of keratin, but they're made of a particular assemblage of that keratin that looks different and is structurally more complex than other sorts that, say, make hair or fingernails. We have a variety of different types of feathers that can be found on birds. We're usually thinking about things like the wing and the tail feathers that have the beautiful shaft. We call this a rachis, and then it has all the little barbs coming off of it. We might also think about down, the type of feathers that we find in pillows, or sometimes we even think about the contour feathers that are on the body of a bird that aren't helping it with flight specifically, but are helping to smooth the body and also form an outer covering for the down that keeps them warm. But a couple of other feathers out here, especially these on the side, bristles and phyloplume, are ones that we almost never actually see because they are very small, and the phyloplume tend to be embedded within the body contour feathers. And we think that both of these form sensory functions to the animal. They're certainly not used in anything like flight. Here's an example of seeing bristle fibers, or bristle feathers, I should say, because they are composed of the beta keratins, just like regular feathers. They are hollow structures. And here we see a bunch of bristles coming off of the face of this nightjar. Nightjars and flycatchers and other birds that actually chase after bugs in the air frequently are small and have a lot of these, and we think that they're acting something like whiskers, like for a cat. So phyloplume is located down inside here and is hardly ever seen, and even to this day, we're not entirely certain of its function, but we certainly know that the bristles that are most often seen as eyelashes, for example, yeah, birds have eyelashes, but they're not made of hair. They're made of feathers. So this is interesting because when we take a look at the fossil record of birds, we have a decent fossil record of birds, but not great because bird bones are very fragile. But I wanted to show you two here. Here we have an example of a type of bird that goes in a group called the Ornithiurae, and it's called Honghornis, coming from the lower Cretaceous units of China. This is some of the same units that also gives us dinosaurs that have feathers, but there are birds here as well. The bird hand-like structure over here is fairly common. The foot is looking very bird-like. The wing assemblage over here, and you might not be able to see this, but over below the hands, there are very distinct wing impressions. So there's good feathers there. But I want to zoom in on the head where you can see this kind of darkish area up on the top mirrored over here. That's actually a feather crest. And when we look at that feather crest, what we find here is that there's a series of parallel lines, little straight lines. So even though this is made of feather, that if we plucked one from the animal would look kind of like one of those body feathers, what we see in the fossil record is something a little bit different in that it looks like a whole bunch of streakish lines. And that's because the feathers have been pressed together, and now it's difficult to tell where one feather begins and another one ends. So we know they're feathers, but we can't tease out one feather versus another, whereas we can do that on the long wing-like feathers, the long wing feathers here called the remiges, because they're big feathers that have a strong shaft going down the middle, and there's a limited number of them going across the hand. So those become more distinct. But in places like the shoulders, the head, around the body, around the legs, we can't distinguish one feather from another. It looks fuzzy, okay? Now, there are other fossils of birds where we don't have any feathers at all. And that's okay. We can still recognize them as birds, much like dinosaurs, on the basis of skeletal components. So down below here is a schematic of the bones that are found from this Oligocene bird called Avaraptor. It has a pygostyle right down here. This is a series of very small fused bones together that form the nub of the tail. Up above that, over here, is the sternum. It's kind of covering over the ribs. The ribs are showing a little bit to the side here, but this is a big, huge, broad, flat sternum that would have had a strong keel in the center, like turkey and chicken when you carve a full one. Out over right about in here, right there, is the hand of the bird. And if you've ever pulled a chicken or a turkey out of the oven, you've got those very pointy ends to the wing. That's the structure here. So even without feathers, there are great anatomical features on birds that help us to know what is a bird. And it turns out that birds are considered dinosaurs because they also share those dinosaurian anatomy components, like having a crest on the humerus or having a perforated acetabulum. Some of them do, some of them have that sealed up. There are other features like the astragalus as part of the tibia. So, this is why modern biologists and evolutionary paleontologists consider birds dinosaurs, is because birds have the features that dinosaurs do, but then they have several others that make them unique. So with that, we turn very briefly here to a quick survey of some of the dinosaurs that we have in the fossil record that show feathers. And there's a lot. Now, this diagram is a cladistic diagram. It's a cladogram. It's intended to show kind of the hierarchical relationships amongst dinosaurs in an evolutionary perspective. So over on this side are the group that we call the ornithischians. This has things like Triceratops and duck-billed dinosaurs in it, Stegosaurus. This group over here, the Saurischia, is the group that includes the long-necked sauropods as well as all of our meat-eating dinosaurs. And for my evolutionary colleagues, they believe birds evolved from this group. But even if I disagree about the evolution of birds from dinosaurs, I can recognize at least that birds have similar characteristics of dinosaurs generally, and they have more characteristics in common with the group of meat-eating dinosaurs than they do with any of the other groups. And over here, we see examples of where we see different types of feathers, including full pennaceous feathers that have a shaft in the center, stuff where we see bristles, and we can actually see that we've got some stuff even in the group that's not supposed to be part of the evolutionary heritage of birds, but rather some dinosaurs that have feathery, fluffy stuff amongst the ornithischians. Well, let's first take a look at this group, the meat-eating group that we call the theropoda. Now, first off, we'll take a brief look at a couple of the groups that stand pretty far outside of the typical evolutionary perspective of, say, the raptor dinosaurs. So these are non-maniraptorans that we're looking at here. This is one of the first animals to be found with some feathers and plumage. And in particular, no, sorry, not one of the first, but one of the more interesting ones here, Sauromymus. The name means squirrel mimic, not because it looks like a squirrel, but because it has this gigantic, big, bushy tail. And when we zoom in on that, here are the vertebrae of the tail, more vertebrae later on down, so C and D here and here. We can see that there are these streak kinds of lines, these fibrous materials coming up and off. They don't come from the bone. They're located just above the bone where the skin would be. So feathers are integument structures. They're coming from the skin. And as you can see over here, as they've prepared it, this is a big, thick area filled with lots and lots of this feathery material. We believe that Sauromymus might be a megalosaurid, but it's a juvenile, so some of the features might not put it in that group. So it's best guess at the moment, but it's certainly not a maniraptoran, for example. It's not one of the dromaeosaurs like Velociraptor or anything like that. We also have something like Eutyrannus. Eutyrannus is a tyrannosaurid, so it's in the same kind of a super family, if you will, as Tyrannosaurus rex is, and some of the other tyrannosaurids. It's coming from China. Beautiful group of 3 nearly complete skeletons found together. So it was a small group that was living together. All got killed, I think, during the flood. And once again, looking at places around its face, around the arms, the legs, and the tail, we see lots and lots of fibers in and around the body. Lots and lots of fibers. In the sorts of places where birds have feathers, this dinosaur has fuzz on it. And are they feathers? I would think so, but it's one might argue that it's something else. There are other creationists and like 2 evolutionists, very few, who think that they might be something like skin collagen. Well, if we go back just for a moment to Sauromymus, skin is located tight next to the body. If there was something underneath the skin that frayed out, this is way too much material. These fibers are far, far too long to have been something trapped underneath the skin. We'll see that with several other examples as well. Bepiosaurus is a therizinosaur. It's one of the maniraptorans, and if you saw Jurassic World Fallen Kingdom, then you watched two bad plots happen in one movie. But what you did get to see were beautiful dinosaurs that were rendered skillfully, the best dinosaurs ever in any Jurassic World film. Bepiosaurus is closely related to Therizinosaurus, which was the big uh, animal that had these massive, long, sword-like fingers, and it killed a deer for no reason in the movie. Uh, and in the movie, it was plumed. It was covered with plumage, in part because of this specimen, Bepiosaurus. So a close cousin to Therizinosaurus is Bepiosaurus, and it has these really, really long fibers around the back of the head, along the throat, and along the back. And it's only a partial skeleton, so we don't have everything to it. It was damaged during construction, or found during construction. But all around what we do have of the animal are these extraordinarily long fibers. And notably, some chemical assays were done of it, and it was found to be composed of the material keratin. So it could either be hair or it could be feathers, but no reptilians groups of any kind have hair. The only things like reptiles or dinosaurs or birds that have these types of structures made of keratin are feathers. The specimens that changed my mind from being a skeptic of dinosaurs having feathers to being fully convinced that they did, and it really was just one specimen as soon as it was discovered, was the Maniraptoran Microraptor, which was fully published in 2003, I believe it was, and also in 2005. This was from a subsequent study. But beautiful, huge, long feathers along the wings, also along the legs, and along the tail, plus fuzz found around the body. And while I was a skeptic of dinosaurs having feathers in the late 90s and early 2000s, when I saw a Microraptor, it went, nope, this animal is most certainly a dinosaur. In fact, it had been described previous to the discovery of any feathers on it. It was actually the dinosaur part of a hoax fossil called Archaeoraptor. It turned out to be not a true find. It was a composite of multiple specimens. Well, this was the dinosaur part. And later on, multiple specimens would be found in their entirety, not just parts that were glued together to make a fake fossil, but legitimate full fossils of Microraptor completely covered in plumage. And from what we gather now, there are hundreds and hundreds of specimens of this from the Yuksang Formation in China. We also know that there are melanosomes on some of these fossils. Melanosomes are small little structures within the feathers that help to give them color. And so we can now accurately reconstruct the color of Microraptor. It has the raven black iridescent colors in it on the basis of what we've seen from the melanosomes. We also know from skeletal structures that things like Velociraptor likely had feathers because they have these little raised dimples, if you will, these raised dots along its forearm. And among birds today, many birds that have large feathers have the same sort of raised spots on their forearm. And these are areas where the bone grows to help anchor more muscles to control the feathers. So the feathers sit on these, but again, the feathers are skin structures. They're not coming from the bone. This is the bone adjusting itself to the stresses of having very large feathers. The structures down below these feathers come from a large vulture here in the United States called a turkey vulture. They have very, very big feathers, and thus they have very large, what are called ulnar papillae, these little bumps on the ulna. And Velociraptor, as well as Dakotaraptor, both fossils within the raptor group, right, the Dromaeosauridae, have these. So it turns out there's a lot of others. There's a crazy dinosaur called Yiki and its group called the Scansoriopterids. They have bat-like wings, but are still covered in feathers anyway. This is the sort of thing that some artist could have invented, and nobody would believe it would have been true. And yet it turns out that now there's three species within this group, or three genera, I should say. And they're all pretty small, but take a look at this skull. This is not a bird skull, and birds don't have bat-like wings with feathers attached to their back. They're different. This is a dinosaur, no doubt about it. Nobody has ever classified it as anything but, and they're pretty small. They're about the size of bats. and functionally would have been fairly similar to bats and birds, even though we would still consider these anatomically dinosaurs. There's lots of others. As I mentioned, there's some in the Ornithischian group, the group that is outside of the group supposed to be evolving to birds. We have things like Coelindrodromeus, which was discovered from Russia, and it's got fuzz all over its legs and even has scales on other parts of its body. So we know that this is an animal that had both scales and feathers. Modern birds have both scales and feathers. So I'm going to skip here for just a moment forward through a few other things. Something that Matt McLean had mentioned in the presentation as well that we gave to ICC is that these feather structures are also not simply restricted to birds and dinosaurs. They're now also being found in pterosaurs. And this is an example of a pterosaur called Tupendactylus. And a small amount of the skull was found on a plate of limestone. This is a kind of a spike that comes off the back of the skull, and the eyeball would have been, oh, sorry, I don't have my laser pointer. There we go. So there's a spike of a crest coming off of the back of the skull. Over here is the orbit. So, and there's a little bit more of the skull over here. All of that is rotated so that we have in white where the skull material is found. We have other specimens of Tupendactylus, so we know this is what the face would have looked like. And then there's all this material that has been preserved as a feather crest with different shapes of feathers on different parts of the crest, and also those preserved color bodies, the melanosomes, of different types in different locations of the crest, so that we can actually say that different parts of the crest were colored differently. So this is amazing. Not only are feathers found in dinosaurs across the dinosaurian spectrum, but they're also found in pterosaurs. God was pluming his organisms with all sorts of stuff. Now, one argument that other creationists have made is that this is inconsistent with Scripture because dinosaurs are land animals and birds are flying creatures. And therefore, they were made on different days, and so they can't both have feathers. I'm not really convinced by this argument on a number of levels. First off, we already know that different groups that we call by big names like mammals include animals that were created on day 6, like beasts of the earth like the wombat or the red panda. But it also includes groups like bats, which were certainly created on day 5 as they are oph, the Hebrew word that is translated as birds here, but it's a much more general feature, sometimes called just flying creatures. So if mammals and birds, which both have hair, could have been made on day 5 and day 6, and we also have mammals in the ocean like whales, then it's not something impossible for God to have created a large group like Dinosauria or birds with members on multiple days as well, right? That's just the fact that mammals is not a created kind, and birds is not a created kind. But rather within birds, within dinosaurs, within mammals, we have lots of different created kinds. Within those kinds, I expect that, one kind, say the tyrannosauroids, they were all made on day 6. They are definitely land-dwelling creatures. They're also plumed, and that's fine. So what we do know, and all creation organizations concur, that there are fossils on some of these, there are feathers on some of these fossils. Many of the creation organizations are moving towards calling anything that has distinct feathers that look like they're capable of flying birds. Anatomically, I believe that's a mistake. To call something like Microraptor a bird in the same way that a titmouse or a sparrow happens to be is quite incorrect. Rather, Microraptor is part of a created kind that has feathers and is much more similar to a variety of what we traditionally called dinosaurs, like Dromaeosaurus, or actually Deinonychus here, or Bootriraptor. These two specimens are actually in the same family. And it would be strange, I think, to separate members of the same family, which we often think of in terms of created kinds, into separate day creations. So as creationists, I think that we can fully affirm that there are feathers on dinosaurs, that those dinosaurs, some of them flew, some of them did not. All of them use their feathers for a variety of purposes, including plumage, color, species identification, thermal regulation and keeping warm, and some of them even use them for flying as well. So with that, I can close out and thank you all very much for your attention here today.
Thank you so much, Marcus. That was
Absolutely.
informative and comforting. A lot of people have tried to appeal to this for evolutionary arguments, but it doesn't necessarily need to be that way.
Indeed. Indeed.
Alrighty. This has been Dr. Marcus Ross talking about creation, dinosaurs, and feathers. Thank you so much.
Thank you. Lord bless.